last but not least, we are going to talk about potential due to a disk of charge. Okay, so if you have a disk now, how are you going to find the potential at point P? Well, I am going to, instead of talking about dq, I could in fact talk about rings. So I'm going to divide my disk into little tiny rings. Okay? And each is going to have dq, and each is going to have a radius dw. Right? So if I just call the radius w, I don't know why, but let's just call it w, then each of these little disks is dw distance away, right? I know dq will be sigma dA. Of course, since this is a disk, I'm going to have surface charge, and so that will be sigma dA. Now, how is this dA going to behave? Well, I have to have because it's a ring, I have to go all the way around. So the easiest probably thing for me to do will be r and theta. And if I had 3 dimension, fine. But in my case, all I need is from the spherical coordinates r and phi. Okay? So this dA will actually be equals to, I'm just going to call it d phi. Okay? And this d phi is the 2 pi angle that my ring has to go through. Okay? I know potential is equals to k sigma dq over r, right? dq is w d phi divided by square root omega squared plus z squared. Okay, where is this coming from? Well, that's easy. This is r, this is z, this is omega. Okay? So for the total, it's going to be omega squared plus r. Now here becomes a little bit more complicated because now you have double integral, right? One over omega dw and the other over d phi. Well, that's easy because they're not each dependent on one another, so we can just separate them out. What you're going to end up with is omega d omega divided by omega squared plus z squared and d phi. So this will go from 0 to 2 pi, limits of integration. This will go from 0 to r, where r, big R, oh, I'm going to call it r, right? So the radius is now going to be called r. Actually, I'm just going to call it omega. Okay? You can solve it. You can use U substitution in order to do it and solve it. What you're going to end up with is going to be k, once you have it solved, omega squared plus z squared divided by square root divided by 1/2, limits of integration from 0 to omega, and 2 pi. Ooh, I'm missing something. Sigma. I knew I was missing something. So sigma will also be here. Okay? So V will actually be equals to that. Actually, I think I made a mistake. There won't be a 1 over 2 pi here. And your final answer in terms of omegas will be equals to sigma over 2 epsilon naught omega squared over z squared minus z square root, and that is going to be your V.